Hello students, good evening. So today we are going to discuss about a unique concept. So the concept is about divide and conquer. So before the lecture, I discussed about the 3D approaches and different examples I taught here. So first we moved with the Huffman coding and fractional knapsack algorithm. Okay. So after these two algorithms, we are moving with the divide and conquer approach. So let's move with this. So first of all, whenever we are starting with the divide and conquer approach, you have to understand certain basic concepts. Okay. So here we'll start with the things like how the divide and conquer algorithm basically works. So basically, this algorithm is suitable for problems where sub-problems similar to the original problem. Okay. That means problem can be divided into sub-problems. That means one big problem will be there. That will be divided into the sub-problems and similar to the original problem. Okay. That means here you have to break a large problem into sub-problems. Okay. And the sub-problems are smaller than the original problem. Like whenever you are working with a particular problem, that problem should be smaller than the original problem. Okay? Then possible to recursively break the subproblem into further subproblems of smaller size. That means, suppose I am breaking a large problem into the subproblem. Then again, that particular subproblem can be recursively break. Okay? That means I can again reduce or I can again convert the particular subproblem into the smaller problems. Okay. That is what it is calling about subproblem into further subproblems of smaller size. Whatever the subproblem will be there, that also we can reduce into the smaller size. Okay. So there is a best case for subproblems when subproblem is small enough. Okay. Whenever the subproblem is going to be very smaller enough, that time main aspect will be work over the best case. Okay. So what are the example of this divide and conquer algorithm? So examples are like quick sort, mod sort. Okay. So these are also coming under the paradigms of divide and conquer algorithm. So this is very important whenever we are understanding a particular algorithm, like how the example is going to be beneficial and how the approach is going to be worked over the particular algorithm. Like suppose you are talking about quick sort, or you can take the example of mod sort, but how it is going to be inherent in the paradigm of the particular approach. That is very important. So now we'll move with the how the divide and conquer and combine. Okay. So first of all, how we are going to be divide and conquer, and then again how we are going to be combining. So first of all, divide and conquer algorithms have three parts. Okay, that is very important. Okay. So this algorithm works over three parts. So first one is divide the problem into number of subproblems that are smaller instances of same problem. Okay. That means here what you have to do first of all, divide the problem into a number of subproblems. Okay. Large problem you have to divide into the subproblems. Then that are smaller instances of the same problem. So that is what? That is the same instance of the particular problem, whatever you are going to solve. That means of the large problem. Then it can create more than two subproblems. Okay. Whatever the large problem you are dividing or you are trying to solve, that can be create more than two subproblems or two or more subproblems. Okay. That's the constraint or conditions you can do. So here the binary sort is not a DAG algorithm. Okay. So DAG means here it will be work over the divide and combine algorithm. So here the binary sort is not a divide and conquer or divide and combine algorithm. Okay. So here this binary sort is not applicable. So here how the conquer will be work, conquer the sub problems by solving them recursively. So how we are going to be conquer it? We have to conquer it by the help of sub problems by solving them recursively. We have to solve the sub problems here. If they are small enough, solve the sub problems are in base cases. So if that problem is very small, then what we have to do? Then solve the sub problems as base cases. So we have to solve the particular sub problem as a base case. Okay. So next step is what? Combine. Okay. So combine means what we have to do? The solution to the solved problems into the solution for the original problem. So here what? Here once you are solving the solved problem as a base case, so that solution will be applicable for the solved problem into the solution for the original problem. Okay. So that is the solution for the solved problem and as well as the solution for the original problem. Okay. I hope you clear. So first of all, here what we are going to be work over it. So first of all, divide, concur, and combine. This divide and concur combine is works with the three aspects. First one I say divide, then concur, then combine. First of all, you have to divide the large problem into sub-problems. Once it is divided or once it is splitted, then you have to work with the concur. That means sub-problems by solving them recursively. Recursively, we have to solve all the sub-problems. Okay. At the end, what you have to do, you have to combine the solutions. Okay. So once you are combining the solution, that particular solution to the solved problem as well as it will be the solution for the original problem. This is very important. Okay. So here you can see in this figure, problem, first we divided into solved problem. Okay. This is the divide. Okay. So next step is our concur. Concur means first solved problem you can see, solved problem, sub problem. Solve a sub problem. So here sub problem we have to solve recursively. Okay. Next one is solution to sub problem. Solution to sub problem. So in this step, what we are doing, we are just combining solution to the sub problem. Whatever the solution we are getting from the sub problems, that we are just combining it. Okay. So that is the solution to the problem. That means that is the solution from the sub problem as well as the solution from the for the what original problem. Okay. Next here you can see divide, concur and combine. So this is very clear. In this particular graph, you can easily understand there is a very large problem is there. So first of all, in this you can see how many times divide is applied. So first problem, here divide, then solve problem, again solve problem. So as it is solve problem can be again split it into the solve problem. So again applied the divide. Okay, here also divide, then again solve problem, again here divide. So because our main motto of this particular algorithm is we can able to be solve the problem into very smaller size. That is what we can split into the sub problems. Okay, up to the very smallest size not came. Okay, so once it came, then what we have to do? Then we have to apply the concur. That means, like see here solve the sub problem, solve the sum problem. Okay, third approach is combine. Once the solve sub problem is happened, then what we have to do? Then only we can able to be combine the solution to sub problem. Once we combined, then next step is solution to sub problem. Okay. So at the steps, what we have to do? Solve sub problem happened. Then third step is combine. Combine means combine. Why we are doing combine? Combine means we will be get the solution for the particular problem. Okay. So this is basically the divide and concur technique or approach you can tell whenever we are solving the particular algorithms. Okay. So here this is the algorithm, how the divide and concur algorithm works. So first of all, divide and concur works with these are all a, comma I, comma j. These are all variables. If base case aij is there, then return solution aij because we have to get the solution for the original problem as well as the sub problem. Okay. That is what return solution. Return solution for aij. This is the original. That means large problem. Else mid equal to divide. Otherwise, if you are not getting means again we have to divide aij. Aij means this is the sub problem again. Because if it is not the final solution, then again we have to divide. Then b is equals to again divide and concur. That means ai mid. Then again what we have to do is equal to DAC A mid plus 1j. That means again we are doing for the sub problems. Okay. So once we got the sub problem for all the sub problem, we got the solution. Then at the end what we have to do? We have to combine. D is equals to combine B comma C. Then finally return D. Return D means what? This is the solution for the original problem or a sub problem. Then you have to terminate the algorithm. Okay. So first one you can see so time complexity f1 of function of n, t of n by 2, t of n by 2, then f2 of n. Okay. And here, if we are seeing the time complexity analysis, so it is moving with the T of n is equals to big O of 1 if n is small. If n is small means it will be goes with big O of 1. If big O of 1 means the function will be f1 of n plus 2t n by 2 plus f2 function 2 of n. So what will be the time complexity here? So the time complexity, the computation will be big O of n log n. Okay. So this is the time complexity for the divide and the conquer algorithm. So now I will be show you how briefly the divide and conquer algorithm works over the particular examples. So first example I said quick sort. So quick sort is basically this is a sorting algorithm. The algorithm picks a pivot element and partitions the given array around the picked pivot recursively. Pivot means it has to choose one pivot element in the sorting. Okay, while sorting, it has to be choose a or pick a pivot element and partitions. So given array around the picked pivot recursively. Then what is mod sort here? Sorting algorithm. So basically mod sort also a kind of sorting algorithm. The algorithm divides the array into two halves. So in this algorithm, the algorithm will be divided into two halves, recursively sorts them and finally merges the two sorted halves. So recursively it has to be sorts them and finally merges the two sorted halves. The next one is example closest pair of points. So in this closest pair of points, how it will work to find the closest pair of points in a set of points in the xy plane. In the particular xy plane, what we have to do? We have to find the closest pair of points. Where now in a set of points in the xy plane. So next one is maximum sub-array sum. This is very important whenever we are working over the divide and conquer algorithm. So as maximum sub-array sum means in a one-dimensional array that may contain both positive and negative integers. So one-dimensional array will be there. There it should have the positive as well as negative integers. So here what we have to do, find the sum of contiguous sub-array. Okay, contiguous sub-array sum we have to find of numbers. Like it may be the positive number, it may be the negative number. But what we have to find? We have to find the sum of contiguous sub-array of numbers. Which has the largest sum? Which one will have the largest sum? That we have to find it out. Okay, so this is about maximum sub-array sum. So we have to work over the one-dimensional array and it will be contain both positive and negative integer. And here what we are doing, we are finding the sum of contiguous sub-array of numbers which has the largest sum. The next we'll move with the Stressens algorithm, okay, or Stressens approach. So Stressens approach means here efficient algorithm to multiply two matrices. So if you want to work over this Stressens algorithm, so this is the very efficient algorithm to multiply two matrices. And last not for least, so Karasuba algorithm. So in this Karasuba, what if we are using the Karasuba algorithm in divide and conquer algorithm? This is a very fast multiplication technique of two n-digit numbers at most. So if you're doing the matrix multiplication or any multiplication, then it should have the two n-digit numbers at most. So this is very important here. Coming to the maximum sub-array sum, here I will show you how the example is given and how you are going to be do the maximum sub-array sum. So in this particular example, maximum sub-array sum is working over the contiguous array elements that provide us the maximum sum given an array. So in this, what you have to get? You have to get the maximum sum, okay, of the particular array. So here the maximum sum, that means if you are adding this particular element, the maximum sum will be 8. Okay. So this particular 8 you have to work. So 21056. So you are adding means this will be 14. So like this you have to add all the array elements. Which one is the maximum sum given in this particular array, that we have to choose it for the maximum sub-array sum. So this we have to solve certain problem, but now we just understand the basic concepts and how it is working over the particular maximum sub-array sum. This example I will do it in a broad manner in the coming classes. So coming to the maximum sub-array sum naive method, how it will be working. So first of all, understand the algorithm. So int find max sub-array sum. So here what I said. So first of all, you have to check with the maximum sub-array sum. And it means whenever we are summing of the array, contiguous array, that should have the maximum element. Okay. So here int find max over a sum, int array size, int n, because array size is given. So that we are taking a variable here as a array int n. Okay, n and array we taken. Then int max over a sum equal to int underscore min. Okay. Then the loop will be continue up to the iteration for int I equal to 0, I less than n, I equal to I plus 1. Okay, up to the maximum sub array sum. Then int sub array sum is equals to 0 for int j equal to I, j less than n, j equal to j plus 1. So this again it will be continue for the j value. Then sub array sum plus equal to array of j. If sub array sum is greater than maximum sub array sum, then it will be moved to the maximum sub array sum is equals to sub array sum, then return maximum sub array sum. Okay, so this is about the maximum sub array sum naive method algorithm. So here what is the time complexity? So the time complexity is big of n square. Okay, but when we solve with the divide and conquer, we check that the time complexity is big of n log n. But for the naive method means it will consume more time. Okay, that is what total count of nested loop iteration moves with n plus n minus 1 plus n minus 2 plus 2 plus 1. That will be moved with n into n plus 1 by 2. So if we are just multiplying, then we are getting the complexity as big of n square. This is very important, and you will be get this kind of questions in your GATE or NET exam. They can ask you what is the time complexity for a naive method or maximum sub array sum. So you have to remember here what is the time complexity big of n square. Okay. So next one is, now you can see maximum sub array sum divide and conquer method. So this we studied about the naive method. So maximum sub array sum also can be solved by the help of divide and conquer method. So in divide and conquer, divide the array into two halves. So here in this particular array, we have to divide into two halves. Okay. So three things might happen. First one is maximum sub array sum is in the left half, make a recursive call. First of all, make a recursive call. Okay. Then maximum sub array sum is in right half, make a recursive call. So it may be in the left side, it may be in the right half. Okay. Maximum sub array sum such that sub array crosses the midpoint. Maybe it can be crosses the midpoint as well. Okay. So that C is mentioned. Crosses the cross. Okay. So here three things will come. One is left side, right side, another one is crosses of the midpoint. That is what maximum sub array sum is equals to max of L, R, and C. Maximum of left, right, and crosses of the midpoint. So that we have to check whenever we are doing the maximum sub array sum problem and solving using divide and conquer method. Okay. So here clearly you can see LRC, that is left, right, and crosses. So here the value is mentioned -2, -5, 6, -2, -3, 1, 5, -6. So here what we have to do, we have to take the contiguous sum of the particular element. So while summing up, -1 plus 4, -2, -3, -2 plus 3, -3. So this we have to do the maximum sub array sum. Once we are summing up, we are getting this value. Maximum sub array sum is equals to 7. Once you will be sum up, you will be get this value. Okay. So here you can check the maximum sub array sum from this 3 also. Which one is the maximum that we have to take it. So here 7 is the max. So we are taking it here. Okay. So here in this example, easily you can understand how it is working, how the divide and conquer. So here we divided into two halves. -2, -5, 6, -2, -3, 1, 5, -6. Always it will be starts from 0, 0, 1, 2, 3. Then here 0, 1, 2, 3. Okay, again sub problem -2, -5. Okay, again 6, -2. And one single element -2, -5. 6, -2, -3, 1, 5, -6. So lastly, if you check, you will be get this particular element -2, -5, 6, -2, -3, 1, 5. That means this is the solution. Okay. So here you see maximum sub array sum example is given. So in this example, you can try to solve it. Okay. How it is working, like how the maximum sub array, and here also maximum value, here also maximum. Here also maximum after the after taking the subarray. Okay, here also maximum, here also maximum. So like this, you have to continue after the end of the particular element. Okay. Once it is ended, then what you have to check? You have to go with the maximum subarray sum algorithm. Okay. So here in this maximum subarray sum algorithm, how it will work? Maximum subarray APR if P equal to R, return AP Q P plus R by 2. L maximum subarray AP Q minus 1. Okay, these things I will tell you how this AP Q minus 1 is working. Then R max subarray A comma Q plus 1 R. C max crossing subarray AP Q R. Then return max L R C. So here the concept is what? First of all, you have to take the variable APR or accordingly your choice. So then you have to take the condition. If P equal to R, then return A of P. Q is equals to P plus R by 2. Then maximum subarray will be happen with what? LRC already we know. So for the L, we taken as AP Q minus 1. R we taken as a Q plus 1. C cross midpoint we taken as a APQR. So return max LRC. So finally we are getting the, while we are taking the return, we are getting left, right, and the C is what? Cross. Process for the midpoint. So here, what is the time complexity? We'll say T of n, A of t, n by b, T of n c log t, n. So T of n is equals to big of 1. If n equal to 1, then it will be moved with the T of n, 2t, n by 2 plus big of n. Then if n is greater than 1, it will be moved with the n log n. So here the solved problem is mentioned of the this case T of n, A t, n by 2, adapted of n c log t, n. So you can check it and you can continue over this. If any doubt, you can put in the comment section. I will try to answer. Next one is corresponding first integer multiplication algorithm. This one I will teach you in the next class. First of all, in this, we are going to be summarize what we studied today. So first of all, we discussed about what is divide and conquer approach and how this is going to be work over the three constraints. Okay, and how we are going to be divide the particular large problem into sub problem recursively, and what are the examples of divide and conquer. Then we moved with the what is the main three parts is involved in the divide and conquer algorithm, divide, conquer, and combine. Then we checked with certain examples and what is the algorithm, what is the time complexity of divide and conquer algorithm. This is also very important whenever we are trying to understand the algorithm concept. Okay, then we checked what are the examples of DAC algorithm. Okay, and how the quicksort is working, Morsort, closest pair of points, maximum subarray, and stresses and Karstuba, and we checked with one maximum subarray some problem, and we solved it. So, and we gone with the algorithm of the NEV method, what is the time complexity of NEV method, and how we can solve the maximum subarray sum problem by the help of divide and conquer method, and what is the time complexity of divide and conquer method, and what is the time complexity over the NEV method. So you guys try to solve it, and if any doubt, you can put in the comment section. We will be discuss the next class. We'll discuss about the corresponding partial integer multiplication algorithm. Okay. Thank you. If any query, you can put in the comment section.